go here. That makes things easier. Okay, let's get started. Good morning, everybody. Hello, how are you? I hope you're ready for something different. I don't know about you, but I mean, problems are fun. I'm sure you would all agree, problems are great, but every once in a while we need a break, right? Let's do something else. So what else can we do with these three-dimensional objects? Well, here's what I'm thinking. I love this website, okay? This Polyhedra Viewer. And I was trying to rack my brain and be like, how can I get you guys to make use of this other than just saying, here it is, check it out, it's really cool. Because not only do we have three-dimensional models of anything you like, pick a Archimedean cell. You like the dodecahedron? Awesome. Here is your dodecahedron. You can grab and spin it around and zoom out and zoom in, okay? But it also has all these wonderful transformations here on the side. We can do things to it to turn it into other shapes. We can truncate it, okay? Chop off all the corners, right? And now it's a truncated dodecahedron. You get this thing, and then we can, I don't know, expand, and it adds more things into the middle, and now we got a truncated icosahedodecahedron, right? How cool is that? Right? We can just keep clicking buttons and contract this side. Now we're back. Let's try a different one. If I contract and then hit the hexagons, now we go to truncated icosahedron. And look, we transformed one into another. That's pretty nifty. And so to try to help encourage you guys to play around with this, this is why I have created the project for this week. Because if you will notice, there's a lot more than just the platonic solids, okay? We've talked about prisms and pyramids, of course. Those are also polyhedron. This weekend I had you look at the Archimedean solids. All right, those are very similar to the platonic solid. They follow a lot of the rules except one, right? We're now allowed more than one regular polygon as our sides, okay? But we still had to fit that, that definition of uniformity, right? Faces are regular polygons, and the vertex are, they call it transitive here. That means you can move one vertex to another, and you still see the same thing, right? There is no identifying, right? Is this the top? Is this the top? Is this the top? I can't tell. And even if I slice off the corners, I can still look at this square or look at this vertex and I see hexagon, hexagon, square. I can spin around hexagon, hexagon, square. It looks no different, right? One vertex is not any different than the others, unlike, say, pyramids. They fail at this test. But there's so many more. There's all these types of Johnson solids named after a guy named Johnson, I guess, right? Cupola, rotunda. Did you know that cupola and rotunda are not just a little bit on top of a gazebo? They are actually geometrically defined. I did not know that until I was looking at the cool stuff on this website, okay? And so I want you guys to experience as much of the cool stuff on here as possible. All these crazy kinds of things. Augmented polyhedra, ooh, what are those, right? Gyrate diminished rhombicosidodecahedra. There's a mouthful, all right? Put that in your spelling bee, okay? This is great stuff. So here is what you are going to do. This is the project. In short, you're put into a group. Your group will research and then present your findings on a particular category of polyhedra, okay? You will be graded on the correctness, quality, and creativity of your presentation, both by me and your peers, okay? So as you present, everybody else is going to fill out a little rubric there. We have it at the end here. So you can see exactly how I'm grading, looking for your content completeness, creativity, correctness, and communication, the 5 C's, as it were, okay? You will be grading each other's projects, so you will also be looking for content, Flow, how well does the person just present? Do they speak well? Do they seem to know what they're talking about as they speak? That's usually a good indication of flow. Okay? And the prop in this case is the presentation itself. Okay? So how well does the presentation, whether that's a Google Slides or a Prezi or what have you, okay? How well does that convey information? How well do their pictures line up? Are they look good? Are they clear enough? Okay. And then of course, because this is a group project, you will also get to rank your team members. How well did you contribute to the project? How well did you communicate with the other group members? Okay. And how well did you cooperate with the group members? So if you are not a team player, okay, you can't screw everybody else over because they will grade you poorly and be like, yeah, this guy, Michael, didn't help us out at all. He was a lazy bum and didn't do his part of the project. And if all your team members say that about you, your grade's going to suffer and theirs will not. Okay, so I will take the whole presentation into consideration. Like, yeah, we're presenting this, and we were supposed to have this slide about this, but he didn't add his stuff there. Fine, I won't hold that against the rest of you. Okay, as long as you fill this out accordingly. Okay, so that's what that's for. All of the major details are here. So the big thing to notice is the categories themselves. Okay, you've been put into groups. You will create your presentation, as I said, Prezi or Google Slides or some other. If you want to actually make a physical poster, for those of you in here, you can do that. All right. But look around that Polyhedra Viewer, or Wikipedia is actually a great source to start with. They have a wonderful, if you look up Polyhedra or Polyhedron on Wikipedia, they've got all these different types. Here you can see the stellated dodecahedra, okay, uniform star polyhedron, here's an option, right? The toroidal, right, that's on the list. And I believe if you go all the way down, right, the bottom of Wikipedia has the best stuff, because it's got all the notes and references, and the categories, right? Go here to convex polyhedra, so you can find your category in there and read all about it. Okay? Wikipedia is an excellent resource to start with. I would not let that be your only resource, because it is very dense. Okay? It is written by mathematicians for other mathematicians, as it like post-grad, you know. So it can be a lot to get through. Much better of a resource is here on the Polyhedra Viewer website, down here at the bottom, and many more. We have these websites, Virtual Polyhedra by George Hart, okay? And he's got some excellent views about different kinds of the Kepler-Poisson. Oh, let's learn about these polyhedra. What are these like? And you can read about these things. Oh, these look cool, right? So do a little perusal. You will have to select one of the topics within your group. Okay? When you know which topic you would like, please report to me ASAP, because I don't want anyone overlapping and doing the same topic within the class period, right? So I know we've only got the blue groups today. So those 3 groups, you'll have to pick your topic. So at least by the end of the day, have your topic ready and selected, and let me know what that is so I can make note of that. Here is what your project must include. Let's go over the criteria here. Your final result must have the formal definition. Okay, so this is using the proper vocabulary, as well as give me an informal definition, something simple like that you could possibly explain to a 5-year-old. Assume they know what a polygon is. You can go from there, but not anything more advanced. Okay. What makes this different? Okay. I will give you an example of a presentation on the Archimedean solids, which you guys researched over the weekend. I'll bring an example to class tomorrow, and so you can see what that looks like. What's the difference between formal definition, informal, how much stuff is written? I'll have the example tomorrow. Okay. How to recognize. This might be part of your informal definition of like, hey, what stands out? Hey, if you have, say, the stellated polyhedra, that's really obvious. Okay, it's very clear to tell when it's a stellate because it's got the spikes coming out of it, right? There's a free one for you. The rest of it might not be so hard. Don't think that's necessarily an easy one. Give us some examples with names and pictures. Okay, this is a category of polyhedra. There should be many, many individual polyhedrons within the category, right? Of the platonic solids, there were 5. The Archimedean solids, there were 13. Prisms, there's an infinite number. Pick some to represent. And give us some non-examples and tell us why they do not fit the definition. This really helps clear it up. Here's a thing that looks like it might be a prism. Oh, nope, it fails. See this part right here? This makes it not a prism anymore, right? Include some of those. And as we've been doing with our problem sets, give us the Euler formula test for at least one of them. So probably pick one of your examples that you had a picture of, count up the faces, vertices, and edges, check does it hold to Euler's formula. Some of these categories will have subtypes within them, okay? If that's there, give us those. Okay, just a quick list of like, oh, and it can also be broken down into these things. And give us at least one interesting historical related fact. Okay? And this can be whether it's first discovered, okay? These shapes didn't seem to always exist. People, had to uncover them at some point. When did we first find that stellated dodecahedron was a thing? Who found that, right? Where did that come from? Or who's it named after? But maybe it's used for something special. Okay, some of these are great. Geodesics. Okay, you can see some awesome applications. Scutoids. Ooh, somebody ought to do the scutoids. Those are fascinating little bit of shape. That's very modern. Okay, the discovery is within the past decade. I don't remember the exact year, but it's within 10 years ago. That's a really cool one. Okay, check those out. And then here is the final percentage breakdown of my rubric, your team score. So this is your score of your other team members, how well they rank you, as well as how well do your classmates score your presentation. And then you have to complete your own score for others' participation that will contribute to your grade. Okay, so if you sit there during everybody else's presentation and you're not paying attention and filling one of these out, that will affect your grade on this project. Okay? Any questions from this main document at this point? All right, let me look closer at the post here on Classroom. So I've broken this into 2 posts, one of which is today's post, due on Wednesday. Note the due date, due March 3rd, 8 a.m. What do you need by then? You need to send me a copy of a draft of your project. Okay? I emphasize copy because whenever you submit something on Google Classroom, it becomes mine. Okay? My account takes ownership of the file. Okay? So that changes the permissions there. So create a copy of whatever you have Tuesday night, post and send that. Right? I need to see that you've got something, right? The start, a title slide, bare minimum, something that is there with your names on it. Okay? I'm getting to that. Right? Everyone must attach this and submit this assignment post. So yes, everybody create a copy. Okay? I want every member of your group to send a copy of what you have so far. And every member, send a copy of your plan to finish. Okay? The plan is very specific. It not only outlines, hey, what's left to do, but who is being assigned which task, however you want to break it down. If you want to break it down by criteria here and say, okay, Michelle, you get the definition part. Sarahi, you're in charge of the examples, right? Edlin, you do the Euler's formula, right? Something like that, okay? Or say, you're project manager, you keep us on task, you're the communication person, you're in charge of typing the words, you're in charge of adding the pictures, okay? And you all just combine, and as a group you move from history to definition to examples. That's fine too. I don't care how you arrange it, but I need you to tell me who is doing what. Okay? And then you hold each other to that. Okay? I want every member to send me a copy of this plan so I know that every member is on the same page, okay? At least as of Wednesday. And then your final product will be turned in. A separate post will be sent out on Wednesday that'll have the due date for Friday, and that's where you'll attach your final project. And then I can compare. Hey, on Wednesday we said that, Ashley, you were going to add the pictures. And then the final project on Friday doesn't have the pictures. And we know exactly whose fault that is. You said, Ashley, you were going to do it. Right? And Ashley, you submitted, you said you were on the plan, you saw it, so I know you saw it. Okay? I'm picking on you because I know you wouldn't do that. Okay? Any questions on that? What is due when? Okay, so today I need your topic. By Wednesday, I need that you started something, plan of how and who's going to finish. Friday, the whole shebang is due, and then Friday, we're all together. We'll try to get as many actual presentations in as we possibly can. 5-10 minutes tops, right? You'll take turns speaking, okay, here's our thing, here's what it is, and you'll just present it as a presentation. Okay? They should go pretty quick. All right, I went over the classroom post. I went over the actual page itself. I will be on standby. Send me a message on Zoom or email, which your pick is. Let me put you into the breakout rooms then. So into one, we have Michelle, Sarahi, and Edlin. Into breakout room 2, we'll send Diana, Naomi, and Ashley, and then 3, remainder Alejandra, Christopher, and Gisela. Okay, so you'll go into the breakout room so you can freely discuss and chat with your teammates. And let me know your final topic pick. Okay? I should probably send a post on Classroom for the other color groups to let them know what has been taken. Yes, I will do that. Okay. All right? There you go. Rooms are open. Have at it.